Okay, so the second way of solving quadratics, and it's not my preferred option, I would only ever do it in an exam if you're told to do it using this technique, is called completing the square. So when you solve quadratics, you can do it by turning your quadratic expression, something like this part here, into a perfect square. It takes a little bit of work. It's useful when we have to do some graphing later on, and it's a process that you might be impressed upon to do. So it's important to do it. So let's think about what the perfect square scenarios are when we expand. So we know that if you have x plus a all squared, that's a perfect square. It always looks like this form. So x plus a all squared is x squared plus 2ax plus a squared. If it's a negative here, we just got a negative here. Now there is a relationship between this form and this form. The relationship that you've got to be familiar with is the fact that when you consider what the coefficient of x is here, see how it's a 2a, in the brackets we only have an a. It's really half of that number there. And half of the coefficient of x is a really important thing to be able to complete the square. So let's have a look at this one here. You're going to start with this sort of style. So we've completed the square when we were graphing circles because we had to complete the square to find what the centre was. This is, I guess, in solving a quadratic context. So if we've got x squared plus 10x, what do we have to add here so we can make it into a perfect square? So what we do is we do this process. If you halve that, you get 5. That 5 really goes here. If you expand this out, that 5 squared puts a 25 there. So if you ever have to complete this statement, that's the process you can go through. What I tend to do is I tend to do this because this will make more sense later. I halve that, I get 5, I square it, I get 25, that's what I write there. So I actually start with the statement x squared plus 10x plus 25, and then I factorise it into x plus 5 all squared. Some people go straight from this to this, but you've got to be mindful that if you add 25 to this, we're going to have to add 25 somewhere else. So I don't like going straight from this to this. Let's have a bit of a think about when it's a negative. We still halve it, so we get minus 7. That's going to be the number that goes in your brackets here. Now, when you square minus 7, you get a positive 49. Okay, so this phrase, so this is equal to this. This is equal to this. That's just showing you how you can go from something where you don't know all the information to factorising it as a perfect square. Let's have a bit of a think about, well, once we actually have it as a perfect square, can I solve this quadratic? Now, if you had to solve this quadratic when it's written like this, you don't have to expand it, kick everything over and factorise it. You can just use the fact that you've got something squared equals 7. Now, if I said to you x squared equals 9, to find what x is equal to, you would square it both sides. So if you square it 9, you get 3. But you need to be very careful that you consider both the positive and the minus version of the answers, because both positive 3 works and negative 3 works. Let's have a bit of a look at this. So instead of it being x squared, it's k plus 3 all squared. So what do we do to find the k? Well, we can square it both sides. So if you square it both sides, the square root of k plus 3 squared is just k plus 3. The square root of 7 is, well, the square root of 7, we don't know what it is, but we just need to write the plus or the minus. Now to get the k by itself, all I need to do is move this 3 over the other side. So when you move the positive 3 over, it becomes a minus 3. You tend to put the minus 3 in front of this expression, but it's not essential. But you'll see all the answers tend to be written like that. So when you move the plus 3 over, it becomes a minus 3. Just tuck it in front. This gives us our two answers. Now the two answers are these. Minus 3 plus root 7, and the other answer is minus 3 minus root 7. So if it's asked to leave it in exact form, there's your answer. If it says what it is to 2 decimal places, you pick up your calculator and you go minus 3 plus root 7 and minus 3 minus root 7. So let's go through the process now of solving this quadratic by completing the square. I would never complete the square because I can see I can factorise this. Actually, no, you can't. So you have to complete the square anyway. Or you use the quadratic formula, which we do next. But if I'm going to complete the square, this is what I do. Rather than leave that 7 there, I tend to kick the 7 out the other side and just think about this x squared plus 6x. So this is the whole process of completing the square. So x squared plus 6x, leave a gap, move the positive 7 over so it becomes a minus 7. Now what I want to do is I want to add a number here such that that will complete the square on this side. Now what do you add to this side? Well, what we do is we halve that 6, so it's always halving the coefficient of x. Halve the 6, you get 3. You square that, you get 9. So what that means is I have to put a plus 9 there. Now if you add a 9 to this side, you have to add a 9 to this side to keep it in balance. So halve that, 3, square it, 9. What we can now do is we can factorise this into x plus 3 all squared. Now minus 7 plus 9 is 2. So how did I get that 3? Well, remember when I halved that 6, I got 3. That's where that 3 comes from. I had to actually square it to get that 9 because I had to work out what I had to add to that side. So I reckon this is a much better way of setting these questions out rather than trying to circumvent this process by sort of jumping straight to a factored form. We know it's going to be an x plus 3 just by halving that, but what's the key number you have to add to both sides is really important. Okay, so now this question is like the one above it. We square it both sides, so we get x plus 3 equals plus or minus root 2. We move the minus 3 over, becomes a, move the plus 3 becomes a minus 3, plus or minus root 2. We can stop. There's your answers. You got your 2 answers for your quadratic. This one's a little bit trickier, and the reason it's trickier is because this 2 is here. Now, the key for, I guess, doing is, this doesn't say actually by completing the square. I would probably use a different strategy. I'd either try and factorise or use a formula, but I want to do it using the completing the square technique, so this is what I would try and do. The first thing is get rid of that 2. So if you get rid of the 2 by dividing everything by 2, we get that. Okay, we've introduced a fraction, but fractions shouldn't bother you too much. What I then do to complete the square is we move the minus 2 on the other side to become a plus 2. And I go through the process again. Now, the coefficient of x here is minus 3 on 2. When you halve minus 3 on 2, you get 3/4. Now, you can do that on your calculator if you like, but really when you halve something, you can divide it by 2 or you can multiply by half. Now, 3 on 2 times 1 on 2 gives you 3 on 4. Think of it as $1.50. $1.50 divided by 2 is 75 cents, which is 3/4. However you get to that 3/4 part, that's up to you. Now, I don't add 3/4 here. Half of that is 3/4. I need to add the square of it. Now, the square of 3/4 is 3/4 times 3/4, which is 9 on 16. That tells you have to add 9 on 16 to that side. Now, this is a pretty tough one to complete the square, and you usually aren't asked to complete the square using this sort of strategy. What do we do now? Well, we put it in factored form. So this becomes x minus, because that's a negative here, it's a negative here. When you square that negative, it becomes positive. Remember, this was a minus 3/4, so that's a squared. Now, 2 plus 9 on 16 is 2 and 9/16. I'm going to write it as an improper fraction because we're going to have to use improper fractions in a little bit. 2 times 16 is 32, plus 9 is 41, so we get 41 on 16. Now what we do is we go through this process of finding the square root of both sides, then moving that minus 3/4 over. So this is what happens. If you square it this side, you get x minus 3/4 equals, this becomes plus or minus, I'm just going to do it up here to show you what it looks like. It's the square root of 41 on 16. Now remember when we did surds, that's really the square root of 41 on the square root of 16. Now square root of 41 you can't simplify, but the square root of 16 is a 4. So what I'm going to do is I'm just going to miss a step, so I don't like writing everything down. I get 41 over 4. That's just square rooting that side. And it'll always be something nice. They're never going to give you something that's really, really gross. What happens now is the 3/4 comes over, becomes a positive 3/4. So we get plus or minus root 41 on 4. I can't think of a single completing the square question where these denominators aren't the same. Okay, so what ends up happening is just write your answer underneath it like this. X equals, because they've got a common denominator, you can write that all on the bottom. So we go 3, that 3 there, plus or minus the square root of 41. Okay, so that's a fairly tough one to complete the square, but it's the process of getting the number over the other side, having a look at the coefficient of x, halving it, squaring it to tell you what to add to both sides, factorising it, square rooting, and then moving that over. Be very, very careful you keep your plus and your minus there because it's going to be part of the solution. Okay, good luck.